Okay, in this video we're going to discuss negative exponents. In the previous examples, everything that we've done has been positive. So what happens when we have negative exponents? Let's do a little exploration here and see what would happen if I had 2 cubed divided by 2 to the 4th power. So in our previous lessons, we've seen that, hey, when we have two terms that have the same base, right? We have 2 and a 2, and we're dividing them, so this is a quotient, a power of a quotient. What do we do with these two guys? We subtract them. So what that means is I'm going to go ahead and subtract these guys, and I have 3 minus 4, which is going to be negative 1. So let's write it out first. So I have 2 times 2 times 2. 2 times 2 times 2 times 2, right? And then we have these three guys cancel. So I'm left with a 2 at the bottom. If we apply the power property, I'd have 2 raised to the 3 minus 4, which is equal to 2 to the negative 1. So if we look at the relationship, if we simplify it out mathematically, we have seen that 2 to the negative 1 is going to be equal to 1/2. So when we see a negative exponent, what are we supposed to do with our term? We flip it. Okay? And that's kind of the key, is that when you see a negative exponent, you're going to think, hey, I got to flip this thing. And so that's how we're going to go ahead and approach these. So let's do another example real quick. And we're not going to write it out like we did in the first problem, but we'll go ahead and do something with variables, and we'll change some of the exponents. We have some more values in here, but another example here. Okay, so if I have x to the 3rd divided by x to the 5th, okay, so if I was going to go ahead and write it out, I have 1 on top and x times x on the bottom, which is x squared. And so we'd have 1 over x squared. Okay. So a different way to write it out is we do, hey, x cubed over x to the 5th. And so we're going to have x cubed minus 5, which is equal to x raised to the negative 2. And then because we see this negative, what are we supposed to do? We're supposed to flip it. And so notice what happens here. The term gets switched to the bottom, the exponent switches to the bottom, and I'm going to go ahead and change the sign of the exponent. The negative became positive. And that's our final answer for this problem. And let's say we had y cubed over, actually, let's change this up. What if I had 1 over x to the negative 2? Okay, so what's the relationship with our negative exponents? Well, we're supposed to flip them. So in our problems, we're going to make sure that there's no negative exponents. So what we're going to do with this is we're going to go ahead and flip it. So we just take this term and flip it to the top. So it would be x squared over 1. Okay? So the negative flips to the opposite side. So if it's at the top, it goes to the bottom. If it's at the bottom, it goes to the top. Let's do another example here with a little bit more involved. So if I had x squared all over x to the negative 3. Well, that's the same as x squared minus a negative 3, right? Because we're subtracting these terms, okay? And so that means I'm going to go ahead and subtract the negative, and that's going to be x to the 5th. I'd actually like to go back to that previous example. I'll do another one like the one that's up here, like this one, but I'm going to change it up a little bit. We'll use a different variable. Let's say we had y to the negative 5th. Well, at the top, y to the 0 is 1, right? Excuse me. And so if I had y to the negative fifth at the bottom, I would do y to the 0 minus a negative 5. And what's 0 minus a negative 5? Y to the fifth. Okay. Because sometimes these can be a little tricky. You need to know what's going to move and what's not going to move. So let's do another quick example here. And we're going to do x squared times y to the third all over y to the fourth. Okay? So, a couple things. This guy, this x, doesn't have anything else here. There's no other x, so I'm going to leave this alone. But I'm going to have y cubed minus 4. Okay, so I'm subtracting the exponents for the y's because these are the guys are the same base. So 3 minus 4 is a negative 1, and because it's a negative, I know that I am going to flip that guy. Okay, and now kind of the quick trick, once we understand that this is what we're supposed to do, let's look at this same problem. Okay, and the idea here is 3 minus 4, so kind of off to the side, I'm going to say, okay, here's some work that this is probably what I'm thinking in my head. 3 minus 4 is equal to negative 1. Okay, so I know I'm going to get this negative 1. Kind of think to myself, the larger exponent's on the bottom, right? So that means all the variables are going to be left on the bottom. I know it's going to be negative, so I automatically understand that that's going to end up at the bottom of the fraction. Okay, so with this example, we're going to apply a little bit of a trick that I talked about in the previous one. And you'll notice here that I have two different variables, and so I'm looking first and I identify, okay, this x, there's no other base x, so I'm going to leave this guy alone. And then I have my y here and y here. So I got same bases, so this negative 3 and 2 I can combine. It's power of a quotient, so I'm thinking to myself, okay, I'm going to subtract these two guys. So in my head, I'm going to say, okay, well, negative 3 minus 2 is equal to negative 5. And then I'm going to say, okay, because I get a negative value, that tells me that I'm going to write the y's at the bottom. And that's kind of my quick trick to just do the math in my head and know where to place the y. And if I look at it differently, okay, so a little different work here. Okay, this is the work of subtracting. Oh, and because it's a negative exponent, what am I supposed to do with it? I'm supposed to flip it. Okay? And that's how we work with negative exponents.